Certainly, thermal expansion is the process in which a material changes in size when the temperature changes. In general, most materials expand when they are heated or contract when they are cooled. As shown in the molecular action section of our poster, when heat is added to a material, its particles gain energy and move more actively. The increased movement causes the particle to spread slightly further apart, making the material occupy more space. This results in expansion. When the temperature decreases, the particle move less actively and the material contracts. Thermal expansion is important concept in civil engineering because buildings and structure are continuously exposed to temperature changes from the environment. Understanding how material respond to this temperature variation helps engineers design safer and more reliable structure.
Thermal expansion happens where there are increasement of the temperature. Substances are changing size and density where there are change of the temperature, especially when the increases of the temperature. The substance also being contracted when there are decreases of the temperature. That's called thermal contraction. The SI unit for thermal expansion is inverse Kelvin. Yes, thermal expansion are related to the kinetic energy. When substance is heated, the kinetic energy of the molecule in the substance are high. It makes the molecule moving faster, and there are more distance between them where the collection between all them. There are three formula to calculate and predict the thermal expansion. First, for the linear expansion, the formula is delta L equal to alpha multiplied by LO multiplied by delta T, where delta L is change of length, alpha is coefficient of linear expansion, and LO is original length. Last, the delta T is the change in temperature. Second, furthermore, for area expansion, the formula is delta A equal to 2 alpha multiplied to A original multiplied with delta T, where delta A is change in area, alpha like linear is a coefficient of linear, but twice for area is twice than the linear. AO is original area and delta T is change in temperature. Last but not least, volumetric expansion. The formula is delta V equal to beta multiply VO multiply delta T, where delta V is change in volume, delta is coefficient of volumetric expansion, and VO is original volumetric.
Several applications of thermal expansion that I know is the use of expansion joint in bridge construction, railway tracks, and electrical of power lines. Because expansion joint allow the bridge to expand safely without causing any damage, even when the weather and temperature change. Engineer will leave a small gap between the rails so the metal can grow longer due to any distance, even when the change of weather and temperature. Engineer designed the power lines enough with looseness because it can be transmitted over any distance or due to any weather and temperature.
It causes cracks in concrete. The water can enter inside the cracks and cause the steel inside to rust. This can weaken the structure and may lead to failure in building and bridges. If there is no space to expand, they can bend, warp, or deform. This can damage how the building looks and how strong it is. Heat makes the frame expand. This can make the window and the door becomes jams or hard to open and close. In heat, sealants become soft and change shape. In cold weather, they become hard and can shrink. These create gaps that let water and air leak in.
I'm here to talk about the method to reduce the thermal expansion. First of all, we can use expansion joint. Expansion joint, we can reduce the thermal expansion by install to allow structure expand and contraction due to temperature change. The second is we can use a material with low thermal expansion, such as high fiber concrete and specialized steel alloy, or use thermal movement and it can improve structural ability. The third one is we can use thermal insulation to reduce heat transfer into structural components. It can help maintain a more stable temperature and reducing thermal stress. For the fourth one is we can use steel reinforcement to help reduce control tensile stress that caused by expansion and contraction. The fifth method is we can use flexible connection, bearings, and support system that allow structure to move safely during temperature change and reducing stress build-up. The next one is we can control the concrete temperature during mixing, transportation, and placement, and curing help reduce thermal cracking. For next one is we can use protective coating to protect the material from direct sunlight or thermal. And the last one is we can use long structure that can be divided into smaller section to reduce thermal expansion over larger distance. Thank you.
The Temenggo Lake Bridge in Perak opened in 1982 along the East-West Highway. It will lead a severe macro cracking structure and material fatigue. Proper engineering, mitigation, and regular monitoring are paramount to keeping our infrastructure safe and resilient. Because failure to accommodate thermal movement result in severe structure damage, high maintenance costs, and safety hazard.
Number that you'll ever do. Two can be as bad as one. It's the loneliest number since the number one. One is the loneliest number that you'll ever do.